Indonesia has various cultures from its local ethnics. Each region has its different characteristics. Madiun is a city located in East Java. Its motto as Kota Gadis, Perdagangan, Pendidikan, dan Perindustrian, Universitas PGRI Madiun (Unipma) plays a major role to develop the quality of education both nationally and internationally. Universitas PGRI Madiun (Unipma) has achieved some award, winning the award of Top University Aku from Cohort 7, getting institution accreditation B, winning national competition grants, and many more. Unipma has 2 postgraduate programs and 4 faculties for undergraduate program with 22 departments. Postgraduate program, Indonesian language and literature education, and social science education. Undergraduate programs, Faculty of Teacher Training and Education, Faculty of Health Sciences and Science, Faculty of Engineering, and Faculty of Economics and Business. To support students' activities and develop students' talents and creativities, there are also some students' activity centers: choir, band, theater, modern and traditional dance, karate, student regiment, and scout. In encouraging the smart and competitive alumni, Unipma also provides representative facilities, convenient classrooms, Campus 1, Campus 2, Campus 3, library, laboratories, micro-teaching and computer, sports center, language and culture center, Graha Cendekia, dormitory, gamelan room. Universitas PGRI Madiun (Unipma) commits to give learning-oriented education and student independence to develop their abilities and skills by organizing some activities such as national and international seminars.
Universitas PGRI Madiun, smart and competitive.
Unipma, smart and competitive.
Good afternoon, Doc.
Good afternoon, sir.
Okay. Nice to see you.
Nice to see you too.
We shall begin in about 3 minutes again, exactly at 13:30.
Yes, sir. Okay, sir.
Good afternoon, Ma'am Mariano. I saw you some colleagues from the Philippines I formerly met when we were managing student exchange under CTG and CTVET, such as Ma'am Mariano, CTG and CTVET. Yeah, years ago.
Okay, sir. Sir, they're asking me to join the main session.
Yeah.
Should I leave the room or?
No. You should be here.
I just click that now. We actually have a new collaboration with Undiksha for this.
See. Yeah, Undiksha Bali, right?
Yes, sir. We have a transfer credit program with them.
Oh, the same with us here, right? Student exchange transfer credit program.
Yes, sir.
Yeah. Also, faculty exchange with Faculty of Economic and Business last semester.
Okay, sir. That's good, sir. From Undiksha, we had Dr. If you're familiar with Prof. Sariasa, sir, he came here before the pandemic.
Yeah. For the pandemic. Now everything
But now
changes.
all is online. Everything is online.
It's already 13:31. We should begin. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. Invited speaker, Dr. Lawrence A. Eclarin from Mariano State University. I think I have here some colleagues from the Philippines, from departments of the Philippines. Thank you, Sir, Madam, for joining this webinar. As well, I'd like to say thank you very much for attending this seminar. Participants from across Indonesia and elsewhere who spare time for this. Well, ladies and gentlemen, I would like to divide this presentation into two. First is the delivery by Dr. Lawrence A. Eclarin. This is about 60 minutes, not longer than 60 minutes. Then the second will be QA, question and answer. For the question and answer, I would like to divide into two. First, we will have some free participants. If you would like to participate by asking questions, please raise hand or write your question on the chat. Well, ladies and gentlemen, before Dr. Lawrence A. Eclarin delivering the material, I would like to read some main points of her CV. Well, ladies and gentlemen, she got undergraduate degree, BS Mathematics, 1998, from University of the Philippines, Diliman. Then master's degree, MS Mathematics, University of the Philippines, Baguio City, 2006, doctorate degree, PhD Mathematics, University of the Philippines, Diliman, 2018. Employment, 2002 Northwestern University instructor, 2002-2014 Mariano Marcos State University instructor, 2014-2019 Mariano Marcos State University assistant professor, 2019 up to present Mariano Marcos State University associate professor. Administrative dedication, 2014-2017 chairperson Department of Mathematics Mariano Marcos State University, 2018-2021 chairperson Department of Mathematics Mariano Marcos State University. Everyone, there are a lot of academic work already done by Dr. Lawrence A. Eclarin, but I would like to shorten until this. The rest you can read her complete CV. Therefore, I would like to go directly to the delivery. For Dr. Lawrence A. Eclarin, the floor is yours for about 60 minutes. Please, Dr.
Good afternoon, everyone. I'm Dr. Lawrence A. Eclarin of the Mariano Marcos State University. So I will be presenting our research on local woven textiles in our province. So let me share my screen. So our research project was titled Developing New Patterns for Local Weaving Using a Mathematical Algorithm. So it is basically a funded project that was awarded to our university in 2015. So for the abstract of my research, Abeli Loco is a local term for the loom woven cloth made by our local weavers here in Ilocos, a province in the Philippines. So Pawai is one of the few municipalities in our province who still practice the weaving tradition. Now, commercialization, globalization, and tourism development in the region have definitely contributed to the promotion of our local products, but there is this demand in the production, which include new patterns and also with newer innovative designs. So our research aimed to develop new patterns and designs for the local weaving industry in Pawai, Ilocos Norte. So this was in collaboration with the local multipurpose cooperative, the Nagbakalan Loom Weavers Multipurpose Cooperative. We were able to generate new patterns using a mathematical algorithm, which I will present later, involving some mathematical concepts like matrices and the like. We also were able to develop a computer application which assisted us in the pattern generation. So we were able to come up with 20 new patterns, although only a few of these were actually put into final production. So as an introduction, so like I mentioned earlier, Abel Iloco or Inabel, those are the terms that are usually used to refer to our local textiles. These are loom woven cloth made in our province, and it is a local cultural identity. Now, the weaving tradition had been practiced for centuries, and it is a part of our history and culture. So some of our local products are presented in this slide. And also here, now there are various techniques used in weaving. So different places or different municipalities practice different techniques, and they have differences also in the final woven products. Now, most of the designs are actually handed down and preserved by weaving families. So we call them weaving families because these are families that pass the practice to their children and grandchildren. Now, Inabel is a very common household item. So we have bed sheets of Inabel, pillowcases, table mats and runners, and during weddings, they usually are given as gifts. Now, weaving is a tedious work, as maybe some of you familiar with the local tradition is, but there are individuals who have actually benefited in weaving, and there are stories also that some families were able to send their children to school because of their practice in the weaving tradition. Now, for the background of the study, so I also already mentioned that this was funded, and our funding agency is actually USAID, the U.S. Agency for International Development, through its Science, Technology, Research, and Innovation for Development, or the USAID STRIDE program. So we were awarded the project in September 2015, and it's a 1-year project, so it lasted until August 2016. So we aim to help sustain the local weaving tradition by developing new patterns and designs for our local weavers. So for the statement of the problem in our study, modern technology definitely affects a lot of our local traditions. And basically because of the demand in the international market, like new patterns, new color combinations, some of our weavers have this personalities wherein they want to do what they have been doing for centuries. So it's really hard to introduce new ideas and concepts to some of them. Although there are also some weavers who are very open to innovations. And another problem is there is a waning interest in the weaving tradition. We have a lot of weavers who are already old and only a very few number of young weavers. And in some references, they even refer to weaving as a dying tradition already. But hopefully, through the efforts of our university, we can try to help sustain the local weaving practice in the province. So we conducted this study and developed new patterns and designs to help sustain the weaving tradition. And in particular, we generated new designs, we conducted trainings to enhance weaving techniques and skills of weavers, and promoted weaving to young people. So we conducted consultation meetings also to our local weavers in order for us to identify problems and somehow help formulate solutions to the challenges that we were facing. So for the methodology, it was conducted in Paway, Ilocos Norte. It's just an adjacent town of Mariano Marcos State University. This is in collaboration with NLMPC, or the Nagbakalan Loom Weavers Multipurpose Cooperative. Now, in the study, the NLMPC Loom Weaving Facility and our university's Loom Weaving Center were used as project sites. So these project sites basically are where we conduct the prototyping, execution, testing, and eventually in the final product weaving. So for our research design, so we had research and development, and then after that, we tried to come up with the development and the design for our local product. So a mathematical algorithm was formulated to generate new patterns. And as stated in my abstract, we also had a computer application that was also designed for us to come up with the drafts faster. Now, the drafts were used for loom execution and in weaving the prototypes for evaluation by the loom weavers, because we do not expect that all the patterns that we will be generating will be easy to make. So we really needed to consult with our loom weavers. And the research project coordinator, Ma'am Leonila Rico, a handicraft worker of our university, actually performed the product testing and prototyping. And for the expert weavers, they were involved in the production of the woven cloths. So I'm now going to present the mathematical algorithm that I've been mentioning. So we need to be familiar. So we do not have to master this. You just have to be familiar with some basic concepts. A 2x2 matrix. So it's basically an array of numbers. You can write it in a square bracket with 4 entries. You have your X, Y, Z, W. Okay, so we have 4 numbers in the array. Now you can get the so-called determinant by getting the product of X and W. So we multiply X and W, and then we subtract the product of Y and Z. So these are basically some basic concepts. So X times W minus Y times Z. Now, a 2x2 matrix can include any kind of number. So it can be an integer, it can be a decimal, a fraction. But what we want is a canonical form. And by a canonical form, we mean integers that should satisfy the conditions. What are these conditions? We want A to be greater than B, and B must be greater than or equal to 0, and C must always be positive, a positive integer. So that is the kind of matrix that we want to work with. And using this matrix, we can come up with the so-called net or sublattice. So this net or sublattice are generated by the vectors coming from the square matrix. So we have the vector A0 and the vector BC. So we will be using these two to generate the patterns. And anyway, I'm going to illustrate this later. So this is the algorithm that we followed in coming up with the new patterns. So first, we set the value for N. Now, for it to be sure, we can choose a very small number for n, like 5, 6, 7. It's easier to manage. So you try to find a value for n, or set a value for the determinant n, and then we are going to enumerate all the matrices corresponding to the determinant. So I'm going to give an illustration later for us to easily understand the process. And then after generating this, we are now going to set it in an n plus 1 by n plus 1 square grid and superpose a number of nets generated to form a tile. So the tile will be replicated to come up with a pattern draft. Okay, so it seems a lot of steps, but let's see. Okay, so let's have an illustration. Let's have n equals 5. So we can have this matrix, 5 times 1, and we have 2 times 0. So 5 minus 0 will give us 5. So the determinant of this matrix is 5. So this is in canonical form with the determinant equal to 5. So how about the nets? So like I mentioned, we have two vectors coming from this square matrix. We have 5, 0 and 2, 1. So these vectors will give the instructions on what we are going to do. So 5, 0 means that we need to move a point 5 steps along the horizontal axis. That is to the left or to the right. And 0, the other number in the vector, will give the steps along the vertical axis, so up or down. So 0. So since it's 0, then we do not have to move up or down, but we need to move 5 steps to the left and 5 steps to the right. So it's like a dance pattern. So our point. Okay, so following 5, 0, we have 2 steps left and right, and 1 step up and down. Okay, so let's start with 5, 0. So the instruction is 5 steps left and right. So that's 1, 2, 3, 4, 5. As simple as that. And then to the left, you should go there. Okay, how about 2, 1? We have 2 steps left and right, and 1 step up or down. But all the 3 points now will have to move along with us. So we have 2 steps right, 1 step up, and then 2 steps left, 1 step down. So it's a very simple process actually if you try to look into it. Now, if you follow these steps, you should come up with this net. So that will be the net generated by 5, 0 and 2, 1. So from 2 by 2 matrix, 5, 0, 2, 1, we can come up with a pattern. So basically, we are not using points, we are using can be generated when your determinant is 5. So this is where the challenge comes in. How do you come up with all the nets that will be generated? Because if you have 5, then 6 nets, then that should be easy. You can start with 5. You just follow the conditions that the number here to the right, upper right, part of the matrix will be less than 5. So you have 4, okay, 3, 2, 1, and it can be 0 also. And then for the lower right, it should be greater than 0. But take note that the determinant is 5. So it can just be, it should only be 1 because we have 5 times 1 and then minus 0 on the other diagonal product. So we just have 1 in all of the matrices except for the last one here, the 6 to 1. We have 1, 0 and 0, 5. So you can try to consider all the possible combinations. So these are 5. Determinant is 5. There are 6 unique nets. So what do? We superpose some of the nets. So we can choose, say, 3. For example, you have 5041 and 5031, 5011, and then you just superpose all of this on top of each other and you come up with this pattern. So if you try to think about it, you have how many? 6 unique nets. So if you compute the combination, say 6 nets and then taken 3 at a time, that will be equal to 20. And there are 20 patterns that you can generate from this. That is only 3 nets. If you take 4 nets and combine them, you can generate 15 patterns. And if you take 5, that's 6. So if you have 3, 4, 5, you already have 41 patterns. So there are a lot of patterns that you can actually come up with. I'll just present how we were able to determine the number of unique nets that we were able to consider. You can use this formula. It's a very easy formula. You just get the sum of all the divisors of your determinant. So if your determinant is 5, the divisors are 1 and 5. So 5 can be divided by 1, 5 can be divided by 5. So you get 1 plus 5 is 6. So we get the 6 nets. If the determinant were 6, then you need to think of all the numbers that can divide 6. That is, it can be divided by 1, yes, 2, yes, 3, yes, 4, no. 6 cannot be divided by 4 as a whole number. And then 6, of course, you can divide 6 by 6. So if you add all of this, you will get 12. So 12 unique nets. And if you compute again the number of combinations, you can actually have, based on my computation, actually did some computations earlier, thousands of patterns already, just having a determinant of 6. So that is how powerful the algorithm is if you're really into pattern generation. So these are our results. You were able to come up with 20 new patterns. So this is one of the patterns that we generated. So from the generated pattern, we went into prototypes and finally came up with the final product. So for the color combinations, we also conducted trainings on how some of the weavers can choose complementary colors. One of our study leaders was in charge in selecting the color combinations for our final product. So some contemporary designs for the bags and other items that were produced were also considered. We even have upholstery of chairs, as we will see later. So here, so these are some of our products also. We have upholsteries on chairs. We have this messenger bag. They call it the messenger bag in gray and green. Then we have our woven textiles using, we call this the X design. Obviously, this exhibits the X. Then we have the diamond. These are simple patterns, but eventually, if you try to include color combinations and you enhance the products, they come out beautifully. Then we also tried wallets. Then we also tried to exhibit our products in our social innovations and partnerships hub here in the university. We featured our Rabel Iloco products in collaboration with other departments. So you can see here a gown using our woven textile. You have a bag, you have bags. And we included also our traditional products as well, because we do not want really to erase the old designs. We know how important they are to our tradition. So we just wanted our project to somehow help invigorate the local tradition and also sustain our local weaving community. So to be in in our product development, to be able to help also our present situation, we try to develop masks also. So what some of our constituents do is they wear the face mask and then have our cloth mask instead of having the K95 mask. That's our university president, Shirley, a groupist. So she is a fan of our woven products. So for our conclusion, it only establishes that when you do research, it really helps in product development and it can help really a lot of people. So for the weavers, they were introduced with the innovative ways of generating new patterns and designs. And during their trainings, they were able to share experiences, discuss the techniques with different weavers because they employ different techniques and come up with different products. So there was this knowledge sharing during the training. So for the research directions, this is what we had in our project. We were aiming at software development, local year production and development because at present, there are no local products, local raw materials available in the province. And also we wanted to help with the marketing and commercialization. But aside from this, you can also try to look into the mathematical aspect because the mathematical component for the algorithm is a very nice research study also. One of my students in the undergrad and the graduate level actually had her research on pattern generation, but she did not use sequences and made use of a different technique also. And in the graduate level, what she did further was to look into some complexities of the generated pattern. So it's more on a theoretical part already. This is a very interesting study. And you can share it if you want. And to acknowledge, of course, our funding agency, USAID, under the STRIVE program. And also we are very grateful with Nagbacalandong Weavers Multipurpose Cooperative because the chairman, Ma'am Charito Carriago, was very helpful and very supportive of this project. So she is one of the reasons, I believe, why we were granted the fund. Because she is a very, very active woman in her senior years already. So this is our references. I'll just try to present some of our research team. So I'm the principal investigator. We have Sir Ragwal is also a member of the department, the mathematics department. Sir Wilben Pagtaconan is from the computer science department. So he was the one in charge with the computer application development. We have Sir Lawrence Jantagata and Sir Mark Lawrence. So there are many Lawrence in this study. So there are actually 3 Lawrences in this study. They were in charge with
Dear participants, we should be patient because it's quite common. Sometimes we lost connection.
Okay, so and then we have, like I mentioned, Ma'am Charito Carriaga. Okay, and then we have the weavers, Ma'am Zenaida, Ma'am Perlita, Glenda, Vicky, and Ma'am Vicky. They're still in touch with us. So if we have some things that we need to consult with, they're always there to help us. And during our trainings, we also tap them as our resource persons. So to put faces into our names, these are our research team. So there are a lot of us. Although there are only a few weavers involved, the whole cooperative was really into the project, and it was really a very happy and interesting experience for all of us. Because honestly, in the research team, only 2 were actually weavers. So many of us have no experiences in weaving, but eventually we learned how to do the basic weaving techniques. So that's all. Thank you.
Thank you, Dr. Eclarin. Ladies and gentlemen, that's all the presentation. Now, before going to the QA session, I would like to comment a very brief. This is an excellent product. Congratulations, Informasi.
Thank you, sir. Thank you.
Well, ladies and gentlemen, if you have any question, please raise hand or you can write your question on the chat. Okay, already, there is already one. Within STKIP PGRI Jombang, the concept of the metric used to make the pattern is it only of the 2 by 2 and why, Doctor?
Yes, thank you for that very nice question. It's actually a very nice, interesting one, because if you try to look at the basic concept of 2 by 2 matrices, it has something to do with your linear algebra. So, sorry for those who are not familiar with the mathematical concept, but just to explain to Wiwin. So, in linear algebra, we have this so-called basis elements. So, these basis elements, they are sort of the cells in your body where these cells replicate to form you, something like that. So, in linear algebra, we need basis elements to form a so-called vector space. So the basis elements are the cells. So in two-dimensional vector spaces, where we work with, we only need 2 basis elements. That is the reason why we have the 2 by 2 matrix. So if it will be a 3 by 3 matrix, that will be 3-dimensional, which is very interesting also if you try to think of it. So it's a 3-dimensional space. But since we're working with a flat space as a cloth, so we have only the 2-dimensional space. So thank you, Wiwin.
Well, thank you, Jack. This is, again, everyone's very much interesting. This is an example of, real example of digital humanities, where we bring the advancements of science and technology to elevate problems faced by our human race. This is another good example. So ladies and gentlemen, if you have any questions, please, while we are waiting for participants to raise questions, I would like to express mine, Doctor. Okay, good. Now, please, ready, please.
Okay. Thank you. Thank you, Ms. Eclarin to ICETECH 2021. I want to ask you about the research. The local weaving tradition in Indonesia similar with tenun or batik ya Pak Sigit ya in Indonesia.
Yeah, exactly.
Can you tell me how the local community adapt to the technology? So I think that is not simple for the local community, and maybe that is problem too in our community. So how long you teach them to use the technology to get new pattern? I think the pattern, it must be to software, and you must tell them to take the technology in the product. Thank you.
Thank you, Nikita Sari. Okay, so one of the challenges that we encountered with our local weavers was really the introduction of technology. So how are they going to use that technology in generating new patterns? So honestly, we had troubles with the non-weavers which we trained. But for the expert weavers, they easily were able to come up or use the patterns that were generated. But using the computer application, they did not actually make use of the application in generating the patterns. What we were able to see was that they were inspired to come up with their own designs, because before they just used the old patterns that they have. And that is one of the realizations of our research. You can introduce technology and everything, but still they tend to go back to the traditional practice. But somehow, in a way, we tried to spark or motivated them to really try new patterns and designs. And they even made use of, when we had the training, I'll share a story. When we had the training and we gave a particular pattern that they can use, they had some difficulty coming up with the prototype. So they made a cloth that didn't really look like the pattern, but eventually they appreciated that new design that they were able to make and eventually have the final product actually, not the exact pattern that they had. And until now, we still go to them. So it's sort of following up on them every now and then, asking them to maybe to collaborate with the trainings and everything. Because if you do the research and then eventually it ends and you do not follow up, everything ends end to end also. So it's really a continuous following up and involvement with them. So we usually tap them as our partners in trainings. That is how we try to establish really the objectives of the project. Thank you.
Okay, once again, Max Claren. The pattern in mathematics is just maybe the shape is box or bullet, circle or box. How about the pattern maybe like butterfly or flowers? Can you make them in mathematics algorithm?
We have a pattern that actually looks
Yes.
like a butterfly.
Okay.
We have a butterfly pattern.
Maybe you can teach us about that.
Our study leader, Mr. Pagtaconan, he tried to really have a figure come out of the algorithm, and then he came up with a butterfly, but you need to edit. I cannot, do I have time, Sir Sigit? I can try to share the computer application that we used, if it's okay.
I think okay.
It's okay, sure. Please, Doctor.
It's there. It's not sharing. Wait. Let's separate this one. There. So our computer application is called PatGen, so for pattern generator. And the good thing about this one is it was developed by our undergraduate students. So some of the research teams in the project came to me and we discussed the concept on how we generate patterns, and they were able to come up with this one. So this is your canonical matrix, A, 0, CD. So you can set the value like what we did. You can have 5, and then this will be 1. So that's 5 times 1, and then let's have a whole number here, but less than 5. So this is the matrix 5021. So we are going to add the net to the list, and then we have this preview window there. And then you can use another value, say 5, 3, and then add to the net, and then you can again preview that. This is just using 2, or you can have, let's try 1. Sorry, that's 1 and 5. And then this has to be less than. Then add that to the list, and then you can preview also. Doesn't look nice. I want the pattern. Let's try another one. I'm biased. How about this one? Still, sorry. Sorry. What did I do? Okay, this one. 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 Okay, this Joseph 5 and what did I not? Joseph 4. So you can actually, what our study partner did was to play around this thing. Then, you can draw the pattern. Then you have that. So it's as easy as that. So it's actually very easy to use. But of course, for the local weavers, they need to have a computer to make use of this one. So part of the software development was actually if we can have a mobile or something that can be used on the Android system, but we did not get that far, so unfortunately. But what we do now really are trainings and more on assistance with our local weavers. But for students, this is a very nice activity for them, wherein you can introduce basic concepts in math, and then they really see something concrete out of the concepts. So math can really be useful practically.
That's
Okay,
very-
thank you. Yes.
Yeah, that's very much inspiring. Now there should be another question by Dr. Wasilatul Murtafiah. What software can be used to create such design patterns based on algebraic algorithm? Doug?
For the software, sir, I'm not really familiar with the computer applications because I'm not a computer science major, which is why we had the team member really in charge with that. But I know that there are many pattern generator applications available online, wherein you can use a particular image and then you just use basic symmetries involving algebra. You can have the reflection, rotation, and you come up with a new pattern. And I believe you can use that for your, was that malo? Batik, for your batik? Yes, sir. But for our research, we had to use squares because it corresponds to the weaving process, wherein we really need to have the pixels there to correspond to the left and right, and then we have the weft. But a lot of computer applications are actually available online. You can try to search them. Tilings, they can have plain tilings. There's a very nice comment by Professor, who's this? Sorry, I cannot see. Jefferson, sir?
Yes, ma'am.
Yes.
Sure. Do you want to comment? Sure. Do you want to comment? You may unmute.
I would not comment anymore since the comment has already been there. Since the product of research is to have other innovations as well as tracing back history of a certain locality, since we are also looking forward to getting back into the explanation of cultural heritage of every locality here in our country. So the use of mathematics as well as the algorithm can also be used as parang investigative pathways to our cultural heritage. That's all, sir.
Yes, sir.
Thank you, Prof. Okay, thank you.
Just to share, sir, we actually have a research for implementation that is funded by our Commission on Higher Education. The fund is actually awarded to the university already. We have been waiting for it for a long time. We will now go into that, the cultural part of our local patterns. So during the research, we were able to see that there are these number sequences that are common in different techniques. So it's like a culture integrated in the textiles already. So you can see similarities of number sequences from one municipality using one technique and another municipality using another technique. This is very interesting. So we came up with a proposal for that already. And it's funded by CHED together with 7 other universities in
Wow.
the Philippines.
It's great. Doc, while we are waiting another to raise question, my question is quite simple. Usually we face this when we go to the field. That is how to sustain the project. Well, it is easy for us to train local people while we are doing the project, but it's not easy to sustain when we finish the project. What you did, Doc?
In sustaining the project, sir, when the funding ended, we had savings. We actually did not need to use that one because from the products that we had, we already had some partners who tried to look into how we can promote the local weaving, and we actually had good partnerships. That is one. The university has good partnerships with our local agencies, the Department of Science and Technology, with the Commission on Higher Education, and the local government unit. It's a collective effort. Because if you're going to look into research really, once the proponent is out in the university, the project dies a natural death. That's what I usually call it. But with the support really of the university, I appreciate the university for supporting our project, especially our university president. Every time she sees me, she always mentions, "Oh, what's happened to your project? What's happened to your project?" She's always like that. So she's always following up. And we always try to see where we can go in. So we call it a niche project. So we have a department niche project wherein we really try to settle in with the community, with our partners, and have consultations every now and then. So it's a collaborative effort.
That's good. It's collaborative efforts. Networking is a key, right? So everyone, if you have any more questions, please. We still some minutes ahead. If you don't, I think it's time for us to put an end to this session. Ladies and gentlemen, again, if you have questions, please, you can raise hand and unmute your microphone. Any more questions? Everyone, any question? No. Dr. Eclarin, it seems there will be no more questions. Thank you very much. I congratulate MMSU because, at least to me, this is a great accomplishment where you combine the contribution of science and technology for the development of local community. In that way, you sustain your local cultures. Again, congratulations, Mariano Marcos State University. Someday we hope we can collaborate doing such project.
Yes, sir. We're open to that, sir.
Okay. Ladies and gentlemen, that's all for the session. But before leaving this room, I hope committee to take pictures. Mas Amir atau siapa saja, monggo diambil gambar. Everyone, please turn on your camera. Mas Amir atau
ya Pak.
Oke,
sudah.
Sampun.
Bentar.
Oke.
1, 2, 3.
Oke, sampun ya. Okay, ladies and gentlemen, that's all for today. Thank you very much. We'll talk to you again sometime.
Thank you so much, everyone. Goodbye. See you tomorrow.